Hey, good morning, everyone. Good morning, good afternoon, or good evening, I probably would say, but I'm based out of Belgium. My name is Peter, and in this Cloud Lunch and Learn session, I'm going to introduce you to the Azure Container alphabet soup, better known as covering the different Azure Container services that we have available in the platform, and starting with an introduction on Docker as well. This event would not be possible without any of the sponsors. So first of all, thank you to both Microsoft and Redgate for helping us out in organizing this event. I would also like to thank our organizational team, where obviously somebody needs to take ownership before an event like this is technically even possible. So thank you to the team behind Cloud Lunch and Learn in collaboration with C# Corner, .NET Mafia, the Dublin Azure Meetup, and Cloud Family. If you want to follow along, feel free to do so. Stay in touch, reach out to the community by using Twitter. I think it's our preferable way to stay in touch. The Cloud Lunch and Learn tweet is on there, and my personal one is PPTXtalk. Hey everyone, welcome in this Cloud Lunch and Learn marathon. I'm going to introduce you to Azure Container alphabet soup, better known as covering everything that you need to know from the starting point, being Docker, all the way to running, migrating your container workloads, and running them in an Azure backend. This event would not be possible without sponsors, so shout out to Microsoft and Redgate for helping us out in organizing an event like this. Next to that, a big thank you to everybody else who's involved in organizing, my fellow speakers, but obviously also you as an attendant, and maybe even more important, the team behind organizing Cloud Lunch and Learn, where obviously besides or apart from taking ownership, an event like this would not even be possible. You can watch these videos later on. They're all streamed on YouTube, and if you want to stay in touch, use Twitter, I would say, where you can find all Cloud Lunch and Learn communication using the Cloud Lunch and Learn tweet handle. And if you want to include my own, that's PDT-IT. And last, a shout out to some other communities helping us out here. The Cloud Family, C# Corner, .NET Mafia, and the Dublin Azure Meetup. So with that, a quick overview of what I'm going to cover in the next 60 minutes. So we're going to start with a lightweight introduction on what I call the journey to the cloud. What it means is explaining like where do containers fit in your digital transformation. From there, we're going to make it a little bit more technical and starting with literally the starting point from containers, and that would be Docker, where Docker is still the container standard nowadays. Once you have a pretty good idea about Docker, what it can do, how it can help you, and what it takes to containerize your application workload, we're going to move them into the Azure backend, and from there running them in a couple of different Azure Container services. Throughout my session, I'm going to walk you through quite a lot of live demos. So I still believe that seeing is believing. If you know how it works, that's all fine. But if you can get an impression how it technically runs on the platform, that's probably even better. So what it means in this journey to the cloud, where if you think back about traditional on-prem workloads, most probably they're running on top of virtual machines and maybe still some physical servers hanging around here and there as well. Now, if you look at a journey to the cloud, which means we're going to migrate running workloads, existing ones or newer ones that we're going to deploy on the cloud platform, it means that we're probably going to start with rehosting, which means running virtual machines almost in the 100% identical way as on-prem, also known as lift and shift. But it's not really, I would say, cloud optimized. So what we need to do is looking into more app modernization, which could mean migrating away from virtual machines into containerized based workloads. But also, although a lot of organizations are migrating and deploying containers on Azure today, as well as in other public cloud environments, or maybe even still keeping containers in their on-prem environment, I wouldn't call them the endpoint for digital migration. It's actually only the starting point. Why? Because containers are closer to virtual machines, and I'll talk about it in the next couple of slides, but it's not the endpoint. what you could do is maybe moving into more platform cloud native services, as we call them, being microservices and serverless. And then just to make the journey to the cloud complete, you could also decide to completely replace your applications and moving to software as a service, where you're just going to consume an application like Office 365, for example, and not really running or managing any of the infrastructure yourself. So with that, my name is Peter D. Tender, based out of Belgium, and currently working as an Azure technical trainer within Microsoft for almost 2 years now. Before I joined Microsoft, I was already running my own company as an Azure trainer, overall cloud architect. And before cloud, I started using Azure about 10 years ago. But before that, I was known as a Microsoft data center guy, literally deploying physical data centers, Windows Server, Exchange, and everything around it. I was an Azure MVP for 5 years on Azure and 1 year as a Windows IT Pro. And in the free time that I have over the last 7-8 years, started enjoying myself in writing technical books, where you can see a little snippet from my most current Azure topics. If you want to stay in touch, feel free to do so. I'm pretty active on Twitter, but you could also send me an email, and that would be petender@microsoft.com, or stay in touch using my blog platform 007 FFF Learning. So let's make it a little bit more technical from here on. And obviously the starting point would be containers. What are containers? How can we use them? And what can they help us with? Now I'll start with mapping a little bit virtual machines, what they are. But since virtual machines have been around for about 15 years or more, I think my first experience with VMware was around 2003, most probably, long time ago. But virtual machines are still there, and again, nothing blocks you from running virtual machines on the Azure platform as well. Now, what's important with the virtual machine architecture, it's where you start from a physical server. On top, you're going to install a host operating system, and the magical piece is hypervisor, which could be VMware, could be Hyper-V from Microsoft, or maybe you're still running some other hypervisor platform. Now, within a virtual machine environment, we start from a full-blown, full-running operating system in which we're going to install or add binaries, and on top we're going to install our application. So we're mainly using the virtual machine as such, as a unit of scale, and it is also hypervisor dependent, which means if I'm running VMware, you're running VMware, we can somehow easily, I would say, exchange virtual machines. But if we need to switch from Hyper-V to VMware or the other way around, it's not impossible, but it would be a little bit harder to go through. What we're going to do with containers is slightly similar, but also slightly different. Now, starting again from the architecture, we still need an operating system as a host environment, but instead of running a hypervisor, we're now going to rely on the Docker engine, where on a Windows client, for example, or Mac OS or Linux OS, it's known as a Docker desktop or Docker daemon. If you want to use this in a more enterprise-ready environment for high available workloads, scalable workloads, you would need to look into Docker Enterprise. But in short, it's just a piece of technology, little piece of software that you install on top of your host operating system, and from there, you're going to run your containerized workloads. Now, interesting is that a container is like a subset of a virtual machine almost. It's not exactly the same as a virtual machine. And one of the major differences, I would say, is that within the container workload itself, there's no operating system. So there's a small kernel, if you want, where the kernel is responsible for interacting between your application and the underlying host, which also means that by design, all containers running on the same host can technically communicate with each other. Another major difference is that we're not going to install binaries within our containers. We're not going to rely on libraries, but we could also inject them in our container, where in a virtual machine environment, we could literally mix and match. Think of like a web application server where we could install Windows Server operating system and installing a different combination of like .NET framework, where you could run .NET Core, you could run ASP.NET 4.5, and literally the virtual machine would be responsible for making sure that there's like no real conflict. Where now with containers, what we're seeing is that you're going to deploy your container, and the container can execute one single task, like running as a web app, running as a database engine. But besides running that one single task, it can only recognize one single flavor. So it means that instead of upgrading, moving from like .NET Core 3.1 into a 3.2 flavor, inside containers, you would create a new container image and not really patching it, updating it. That would be the mindset. The biggest reason why organizations are looking into containers is because they're easy movable, which means if I'm running the Docker engine, you're running the Docker engine, the public cloud environment is running the Docker engine, we could all start mixing and running containers all together. The next challenge is knowing and understanding a little bit what it takes to run your containers on Azure. Now, there's a lot of opportunities there. First of all, because again, it's all based on the same Docker standard. So starting from the bottom, it gives developers a friendly environment once the container is there, or you want to build up like a Docker compose where you're going to mix multiple containers together, and all containers together are building up your application workload. You could do that. And it's starting from the developers, and you as the application consumer, you might even run containers and start using them. The dependency for a container, and I'll talk you through a little bit more later on, is a Docker Hub, where you're going to find what I call baseline images, but could also be full application ready, end-to-end application ready workloads already containerized for you. If you don't want to rely on the public Docker Hub, although you could configure it in a private way as well, you could move containers into a container registry. Since I'm primarily talking about Azure, later on you'll find out we're going to use Azure Container Registry. If you use AWS, if you use Google Cloud, if you use any other container hosting environment, you're going to find out that they also provide you container registries, where the container registry is like a library of container images, and from there you're going to present them to a runtime, where Azure again provides you a whole bunch of options on how you can run your containers, starting from one of the easiest, I would say, and I'll show you in some demos later on, that would be container instance, allowing you to run your container as a standalone instance. And the biggest benefit, I would say, is the easy way to deploy it, the easy way to manage it, and it's pretty cost friendly. If you have short running containers, it means that you're only going to pay for the actual compute, and that would be a per second billing mechanism. If you need a bit more advanced, scalable, more high available container scenario, you might look into app services, where app services is going to give you everything that you might already know from running web applications, but instead of running web apps on top of the source code, you're going to bring in your container image. If you look into more orchestration, even more high available, more high end container workloads, you could look into Service Fabric or Kubernetes Service. Service Fabric has been around in the Azure platform for years and was primarily known as a .NET hosting environment. Initially only for hosting .NET applications, and for a couple of years you could also use it to run your containerized workloads and even running them next to each other. Kubernetes will be one of the last topics in my session, walking you through the architecture, but also walking you through some demos. And on the side, as you can see, there's a long list of the partner ecosystem, which means that you could create your own hosts. You might be familiar with like Red Hat OpenShift, Docker Swarm, Mesosphere, and again, a long list of partner-based solutions. And what most of them do have in common is that it's based on a virtual machine architecture running on the Azure platform, and within they typically run a Kubernetes application stack in which you're going to run your applications. So with that, you got already a little bit of a teaser for what's coming in the next 45 minutes. And the main question I would say is, like, where do we get started? Like, what's the beginning in this journey to the cloud in this containerization workload? Where no secrets, no surprises, it would be Docker. So Docker is an interesting one. So Docker allows you to literally wrap, like almost create a bubbled version of your application. and it recognizes a Linux-based file system and allowing you to run your containers, testing them out, really running them on a production system, and integrating all system tools that you need, integrating all system libraries that you need. You could run it on a client operating system. What I'll use later on for some of my demos would be Windows 10. You could run this on a Linux-based platform, you could run this on a Windows-based platform, and obviously macOS is also supported. And then even more obvious, you could move your container images into an Azure cloud environment and from there running them as well. Now the starting point with Docker would be first of all installing your Docker engine on your local machine, and from there starting to learn a little bit about Docker command line interface. Now it's not the only option, I'll walk you through some other scenarios later on, but I could encourage you to start at least learning a little bit about Docker command line interface. It's not really hard, I would say, at least for the day-to-day integration, day-to-day management of your Docker containers. So you would run docker info, I'll show you in a minute, to get some information. Is my service running? From there you would switch to Docker version to maybe run some upgrades. Docker push, Docker pull to interact with your container registry. Those would be like the prime commands. So I promised you a couple of demos, so why not switching to a first one where I'm running my traditional command prompt, and I'll try to make it a little bit bigger. There we go. So what I did, I might actually start with that one, is running Docker desktop. Now let me switch to my Docker desktop and showing you what it looks like. There we go. So Docker desktop is this nice graphical interface allowing you to somehow manage your containers, or at least part of them. So it's going to show you a history view of your container runtimes, where you could also find out if they're running or maybe they're not running anymore. And you could also pull up a list of local container images that are running on your local machine. You could run some upgrades, checking out the Docker desktop versioning and validating like how many images do I have and how much storage space am I using. And next you could also create your own developer environments, like mixing the Docker engine on your local machine and using it to run Visual Studio Code, to run Azure CLI or anything else you're using, but not gonna talk too much about that part. Now I told you that it's also relying on command line interface. So what we can do here is somehow running the same, where I always start from running docker info. That would be some kind of validation if your Docker services are running. Now interesting here is that I'm running a Windows client where technically my Docker kernel is running on a Linux subsystem. How does it work? It's based on the Windows subsystem for Linux. You go to the marketplace, you install the Ubuntu WSL, and it's somehow turning your Windows client into an Ubuntu-based Linux environment. If you cannot run or you don't want to run WSL, you could still rely on the older way, where it's injecting Hyper-V on your Windows client and from there running a Linux-based virtual machine. Now the nice thing on a Windows client is that you can switch from Windows depending containers into Linux depending containers and back. So you could literally build out your full developer-friendly environment no matter what the underlying application operating system looks like. From here we could check back on the images we have. And as you can see, I already have a few of them. Some are built by my own, some are coming from the public Docker Hub. From here we could run a container. So let's do docker run Ubuntu, one of the easiest examples, I guess. And what it's allowing me to do here is validating my container. Now there's something happening for like a split second, and from there you don't really notice anything. So what we can do is validating with Docker PS, and it's going to provide an overview of actively running containers. Now, apparently not too much is running, I would say, on my machine, and that might be a little bit weird. So why not checking back with another, maybe more familiar Linux command would be docker ps -a, and it's going to show you that this container started up like 32 seconds ago and the status is exited. Why is that? Because we didn't really tell the Docker container what to do. So the easiest way to run this in an interactive mode is executing docker run interactive Ubuntu again, where Ubuntu would be the name of my offline image, and this time I'm actually entering my runtime, my running container. From here I could run some base Linux commands, like top would give me a list of my running system resources, and from here I'm still inside my container workload. I could open a second command box. Let me quickly do that, and just moving it out of my second screen. There we go. Where now I could run docker ps -a once more. We're going to see that it's now showing a lot more information from my environment, and the most relevant one would now be this active container. You can see that it started about 55 seconds ago, so roughly about a minute. The previous one that I was spinning up that already had an exited state in meantime is also still visible. And if you want, similar to what I showed you from the GUI, it's going to show you some backwards list of all your workloads. From here, if you want to run your container workload, let me first exit my Ubuntu container, and why not running it again? You're going to see that each and every instance of a runtime is immutable. What it means is that before I was running my Docker container, my Ubuntu container, and it was known as container 4E977, where from there you can see that now my container image, the new one I started up, also has a different ID. So it's almost like starting up or building actually a new virtual machine. Once we stop the container, it's like completely gone, and from there when we run the startup command again, it's literally building up a new container runtime. So the image is the same, like a virtual machine disk, but the actual virtual machine instance, or now the container instance, would be a completely new one. So those are like one of the, I would say, core scenarios around running Docker. But it might be interesting to maybe switch to the other part in the Azure platform and showing you a little bit about container images. Now, what is a container image? Again, it's like this completed bubbled environment that's having operating system kernel inside the container runtime. The binaries are there, and obviously your application source code is also available. Now, once you have your container image, like my Ubuntu image, for example, we're going to move this into a registry. Now, before we can move this into the registry, we need to take a couple of steps back and compiling our container. Now, what we need to do there is using a Docker file. Now, I'm going to use Visual Studio, and just give me a second to pull it up. So I'm running a .NET based workload, but it technically works for about any application development platform you could think of. And this would be a pretty straightforward web application connecting to a SQL backend. As you can see from my default connection string here, it's reaching out to some Azure database, just in this example. Now, to turn this traditional web application into a container, it means that we're going to containerize it. Now, how can you containerize it? It relies on, again, a set of Docker commands, or if you're using Visual Studio, where Visual Studio is running on the same host as your Docker engine, like in my case on the Windows 10 machine, it's allowing you to inject Docker support. From here, what I explained earlier, you have a mix between Windows and Linux. My application is based on .NET Core, which means I could run it on a Linux machine. And again, the dependency would be WSL or that Linux virtual machine running in Hyper-V. From there, when I push my OK button, it's producing a Docker file. Now, what is the Docker file? It's a set of instructions for our container workload, where we're gonna tell the Docker engine, like once you wanna build up this image, I want you to go through the following couple of steps. And let me zoom in a little bit on the Docker file example I'm using. So we start from a baseline container, which is a .NET ASP.NET 3.1, because it's literally what my application needs. From there, we're gonna switch to a second container image, where we're gonna inject the SDK for the .NET 3.1 again. So it's literally an ASP.NET, which means I can understand .NET Core, and the only thing I can do is running a web app. Where next to that, for compiling my application as part of the containerization process, I'm gonna inject the SDK. From there, depending obviously on your application, if it's a Java app, a Node app, the process would be about the same, but obviously the baseline images would be slightly different. From there, what I'm doing is literally copying all my application modules into a source directory. It's a pretty big application, so I got a lot of lines there. Where next we're gonna compile our application running .NET Restore. A little bit later on, we're gonna run .NET Build, and eventually we're gonna create a .NET Publish. So if you're, again, familiar with your development environment, technically you would do about the same, where you have your source code, you're gonna copy it over into your web application server, you're gonna compile the application, you're gonna publish it, and technically within the container subset, we're doing the exact same thing. And then all the way at the end, there's another characteristic, it's called entry point, and that's where we're gonna instruct the container what you need to do. Think back about my Ubuntu example, where I didn't provide any details at first, so the container comes up, no instructions what to do, and it's gonna stop itself. Where in the second option, I ran docker run -IT for interactive, and it tells the Docker runtime, whenever this container comes up, we need to open up the shell environment from this operating system. And that's what we're doing here with entry point, telling like, hey, container image, when you come up and you become like a runtime container, I want you to execute .NET command and picking up the simple commerce, which is my sample application workload. And I'll show you once more in the command prompt what it looks like. So we have Docker images, and the outcome of my Visual Studio action is the first container. Now I also moved this container into the public Docker Hub. So if you go to Docker Hub and you search for the PE tender simple commerce, that would be this one, you can actually go through most of the demos that I'll use from here on as well. So with that, let's switch to container registry, because right now we do have our container image available and we want to run it. So what is container registry? It's a subset of a service in the Azure platform, allowing you to manage container images. So from there, once you have your image available in the registry, you're going to present it to your actual Docker host environment, which again could be virtual machine based, like a Red Hat OpenShift, or why not if you build your own Windows or Linux based Docker host. Once you're going to start and running your containers, you're going to build up an integration from the VM layer into the registry layer. Or if you want to run them, what I'll show you in the next couple of minutes, running them in container instance, running them in WebApp for containers, or eventually running Kubernetes. Now, container registry, think of it as some kind of file storage scenario where you're going to store your images. Now, depending a bit on the needs and wants, you could choose from a basic, standard, or premium flavor. I would personally recommend Premium, first of all, because it's a bit faster, gives you larger storage capacity, which means you can store a lot of images on the container registry. And another interesting one is if you have a larger Azure landscape, it also allows you to synchronize images across different container registries. Now, the registry itself is 100% Docker supported, so it's identical to the public or private Docker hub. Again, in short, a landing page for Docker images. So we're going to start with creating a registry where the registry itself is using the default Azure namespace called azurecr.io. Within the registry, we're going to create one or more repositories, where a repository is a group of container images. And from there, we're going to store our offline images and eventually presenting them to our runtime, and that's where it becomes a full running container. Now, container registry comes with a couple of interesting capabilities. There's one really useful one, and that's called Quick Task. So what it allows you to do is moving to some kind of automation, which means if you have a lot of activity going on the container runtime, running container updates, compiling new containers, and you somehow want to automate it from your local machine, moving it into the registry, maybe integrating vulnerability code scanning, which I would personally really recommend, and a lot of other options. That's where the quick tasks are coming in, like a little bit of automation for the container registry service, helping you in automating your container lifecycle. That would be the main message. So with that, let's switch to my Azure environment and talking a little bit and showing a little bit around container registry. Now, what you would do as a starting point is obviously creating the resource service, where it's going to ask you a couple of settings, like pretty much anything else in the Azure platform. You would need a unique name for the service, a resource group, the subscription, and the region where you're going to run it. Now, interesting enough, there's also some networking integration. So you could decide if you want to keep all your container images, like in a more isolated environment, you would probably go for private endpoint, and otherwise you would go for public, which means that all networks within Azure and also from the outside of Azure could connect to your registry. Now keep in mind, if you want to use that private endpoint, you need a premium flavor. What I did is obviously already deploying a registry service. And since I'm using that Simple Commerce, which by the way is an open source .NET e-commerce application, you could containerize it and from there moving it into the registry. So we have our container registry, and once more validating ACR tasks like running some automation, the container build, run, push and pull interactions, but automating a little bit, and definitely recommended to activate, but it's an additional monthly cost for using the third-party plugin, where Aqua and Twistlock will allow you to run code scanning, code vulnerability scanning, which means it's going to detect any suspicious component inside your container layers, allowing you to inspect any overall code vulnerabilities running inside your applications. Or maybe if you're interacting with the base images coming from the Docker Hub, it might also be a good practice to scan them for any vulnerabilities before you actually gonna use them. Now, moving a container from your, let's say, development workstation into the container registry is again a Docker command. So you would run Docker push, that's really the command, and you need to authenticate. Now, how do you authenticate against your ACR? That would be based on an access key. So what you need is a username and password. I know I'm showing you this information, but it's technically not even running anymore, so I wouldn't really worry about it. Once we run Docker push, it's going to store our container, offline container image in the repository, and from there we can start running it. So remember, we're talking about this simple commerce. That's my baseline container that I build on my local machine out of the Dockerfile interaction with Visual Studio, and I ran Docker push again just to speed up the demo a little bit. From here we can run a new container runtime, and that would be container instance. So why not switching to container instance and talking a little bit what it can be used for. So container instance, or ACI, is overall one of the easiest ways to run a container. You have a container registry, could be Azure, could be the Docker Hub, or any other private one that you have. As long as you present the correct credentials to ACI and there's network connectivity available, it's allowing you to spin it up. Although it's pretty easy, pretty straightforward to use it, to run it, it also provides you some detailed logging. So you can follow up when your container instances are starting up. You can see when they're stopping, if there's any issues with them. So pretty basic, but powerful. And the best benefit I see is that it allows you to literally spin up your container and running them. And let me show you what it takes from here to start up a new instance. So you could start from the container registry and running an instance, where similar to, again, any other Azure resource, you need to provide the subscription, the resource group where you're going to run it, the location, where I would recommend keeping it in the same location as where the registry is. And you could also look into that premium flavor of the registry, allowing you to recognize, interact with different registries across different regions, where the biggest benefit is that you don't have any latency in copying the image file over to the actual runtime Azure region. And then last, you can specify some compute core and memory, where you can decide anything from 1 CPU to 8 CPUs, and I think up to 16 gigs. And then last, you're going to specify if your container comes up as a public IP or not, which means that you could directly connect to it, and any specific port, like in my case, it's a WebApp, so that would be port 80. Another option you have is starting from container instance. Instead of starting from the container registry, and worst case, I'm going to try and show you live, but if needed, I already have another example running. So let's quickly complete some of the settings and building a new instance, where we're going to create a new resource group. Let's call it Lunch Learn. Makes it a little bit easier for my governance later on and cleaning it up. The container name, live PDT demo. I'm going to run it in West Europe because that's where my registry is. And from here, you can see that we accept a lot of different images. So there's a few samples available out of quick start options, like a pretty straightforward Hello World example. But obviously, I'm going to use my container registry. Since they're running in the same Azure subscription, I don't need to provide any credentials because it's already communicating with each other. If you got different container versions using tagging out of the Docker capability, you could also go back to different versions. I'm using latest, which would be the default. I don't have a super powerful container requirement, so I'm going to keep the defaults. Already talked about networking, so to make it a little bit easier, I could switch to public, private. If you don't have any network dependency, like a standalone container that just needs to run some calculations or anything like that, you don't even have to provide any network details. In the advanced setting, that's where you can define additional instructions to the Docker runtime, like for example, switching to test and dev database backend, or switching to production database backend. That would be the idea. Once you push your review and create button, it takes about a minute to spin up your container instance, and the outcome would be what I already have. I talked a little bit about monitoring management. So what you can see here is a tracing of what happened with your containers. So whenever you're going to start up a container instance, it's performing like 4 or 5 different steps. So it's going to start creating the container instance, happened here on line 4. From there, it's executing a pooling command, which means the container instance service comes up, reaches out to the registry, copies over the image, and starts running it. Once your container is running, you can also inspect what's actually happening inside the container. So for my workload, I know it's a web app and it's interacting with a SQL Azure backend. And what I always like to validate is if the connection to my database is working. And that's what I can see here, similar to like debugging information in your development environment, or logging on to a virtual machine web server, inspecting the logging, and we're now providing you similar capabilities. If you need to troubleshoot your container instance, you could also connect to it, and from here you get access to the file system. From here, I could do ls, like reading out the folders, files, and I could actually browse from here, but not really gonna do that. Last, let me show you my application workload. Again, I define it as public, which means that if all goes fine, I can connect to my public IP address, and that's my application. Web app frontend running out of the container, connecting to SQL Azure backend, could be any other database, could be a virtual machine, doesn't really matter. As long as they belong to the same VNet and you allow correct network integration with Azure, it should run perfectly fine. Now there's another option where from here I did the ACR integration, creating a new ACI, but if you need to deploy and test multiple container workloads where you quickly want to use your ACI environment, it might become a little bit overwhelming or meaning too many manual steps to be done. What Docker and Microsoft integrated already, I think almost about a year now, is what we call a Docker ACI context. What it allows you to do is, first of all, creating like a site environment. Think of it as a dev and test environment, maybe production, why not? But instead of going through all the steps in a manual way, you could now run Docker context with a specific given name. As you can see here on the slide, it's a PDT demo context. And from there, you're going to execute your Docker run action steps, where now instead of deploying everything in a manual way, like I showed you before, it's actually running it for you. Now, I already walked you through the Azure Container Instance demo, and just for some time consideration, because I only got about 15 minutes left, I'm going to skip the Docker context demo for now, but what it does is, again, allowing you to run all the steps that I showed you in a manual way and actually automating them from the Docker command line option. So with that, let's switch to another possible workload service in Azure called Azure Web App for Containers. Azure Web Apps is literally allowing you to host web applications where you typically bring your own code, whether it's Ruby, .NET, PHP, doesn't really matter. So what we're going to do now is still using Azure App Service, the web app component, but instead of bringing code, we're now going to bring our container. So easy said, it runs everything from the web app application, but instead of relying on source code, it's going to run your containers. You could integrate CI/CD pipeline capabilities. If you're familiar with web apps, you probably know that there's a service feature called auto-scaling, integrating with load balancing. The high availability out of the box is a little bit better than what ACI gives you, because again, it's just that one single runtime. Everything around custom domains running, Azure Backup Services integration, public repos, private repos for the registry, it's all available. And one other big benefit is Docker Compose, where again, it allows you to run multiple containers and considering them as one single application. And that is not supported in ACI today, but it is supported in Azure Web Apps. So, similar scenario as before, where now I'm going to create a new web app. There we go. I'm using the portal, but obviously this could be based on infrastructure as code, where you're going to use Azure PowerShell, Azure CLI, maybe ARM templates. We're going to run it in our lunch and learn. Oh, that's right. I switched back to my previous example. but I'm not even going to deploy it. Most important here is, instead of reflecting code, you're going to rely on Docker container. And in the next step, similar to what I showed you with ACI, it's going to ask you for your container image, configuring monitoring, configuring networking. So pretty much everything you have from web apps overall. But now instead of selecting your application framework, you would use container registry. Now that's all fine. We talked about ACI, talked about web app for containers, but in a lot of cases, it's not 100% production ready yet. So if you need even more powerful auto-scaling than web app for containers, if you need rolling updates, which means you want to patch your backend, you want to upgrade your containers without downtime, maybe you need more advanced load balancing out of the box, it means in short you need some kind of orchestration like an end-to-end management tool. If so, the answer would be Kubernetes. So what is Kubernetes? It's an open source product, originally coming from Google, but been open source for quite a while already. And what we're doing with Azure Containers, Azure Kubernetes Service, AKS, is offering you 100% Kubernetes supported, 100% identical Kubernetes environment than what you could run in Red Hat OpenShift, what you find on AKS on AWS, what you find on Google Kubernetes platform, but this time running it on top of an Azure platform. Now, the architecture somehow could be a little bit overwhelming, so I'm going to quickly walk you through. So on the left-hand side, we have a master node, and the master node is what I call the Kubernetes brain. So that's where the control plane lives, the management plane lives, and it's validating the Kubernetes cluster, a high available virtual machine-based worker node architecture. That's where the DNS for the Kubernetes cluster lives, the interaction with all the network stack, connecting to, for example, Azure Load Balancer, App Gateway, or like an Nginx scenario you might have heard of. Now the brain or the control is not really doing anything besides steering, guiding the worker nodes. So if you want to run containers, and they would run within a worker node, that would be up here. So what we're going to do is instructing our Kubernetes cluster, like when you come up, I want you to have X amount of nodes, where the default would be 3 different nodes, meaning 3 backend compute virtual machine options, in which you're going to run your containers, where in Kubernetes terminology, we talk about pods. Now, a pod can be a single standalone container, but it can also be a collection of containers that all together build up a service. So obviously that's where the high availability, the flexibility, the scalability comes in. So what is Kubernetes, or AKS specifically? It's an Azureized service giving you everything from Kubernetes, but starting from the Azure backend. It gives you Azure built-in monitoring, Azure virtual machines, Azure networking, Azure storage, Azure load balancing, but you don't really need to manage it. It's all coming out of the box once you start deploying your AKS service. Managing it, deploying it is based from the portal, CLI. If you want, you could use ARM templates, Bicep templates, Terraform templates. So that would be the initial deployment. From there, you could start small with a single node, not giving you high availability. Obviously, the default behavior out of Azure would be 3 nodes. And from there, you're going to scale out up to 50 virtual machines in the backend, where you can even decide on the virtual machine flavor you want to use. Once you have your AKS up and running, you're going to start injecting instructions out of, for example, YAML files. Think of them as text-based config files with instructions. Or if you need a more CI/CD pipeline-like scenario, it might be good to look into Helm charts. And again, Linux and Windows are obviously supported. So once more a bit about the full architecture. So I would say the developers are responsible for building the actual container workloads, everything I talked up till now, where you're going to start from any development environment, compiling it into a Docker image, and maybe integrating CI/CD pipeline concepts using any DevOps tool that you want. From there, you're going to interact with container baseline images out of Azure Container Registry. So there's like a continuous movement between the developer creating new images, moving them into container registry. And from there, you're going to deploy Kubernetes, and that's where your containers are running. The AKS cluster is continuously communicating with the container registry, picking up new image versions, maybe running new container workloads, and taking ownership for the runtime, the high availability, the scalability, and anything else that comes with the AKS benefits. And then last, your sysadmins are probably taking ownership for monitoring your Kubernetes cluster. Now, out of your Kubernetes cluster management, there's a couple of different options to start going. So what you first of all need is a Kubernetes YAML file in whatever name you want to give it, in which you're going to specify some settings. And look at the snippet here on the slide. What it shows you is an app name, in my case AKS Hello World, just an example. And within, you're going to define some parameters for the actual container runtime. What's important? The name of the container, and even more important, the name of the image, which in my case would be part of my ACR backend, where I'm going to reuse the exact same simple commerce container that I used before. I also need to provide the container port runtime. Like once the container image comes up in AKS, we need to instruct AKS like, when this container comes up, I want you to run it on port 80, similar to what I showed you with ACI. From there, you can also specify additional parameters. There's a huge amount of documentation on the Kubernetes website, even on the Microsoft Docs, around how to build up your YAML files. And again, maybe in a more enterprise-ready environment, look into Helm charts. Once you have your YAML file, you're going to rely on kubectl. That's the Kubernetes, overall Kubernetes command line. It's nothing specific for AKS, it's overall Kubernetes standards. What you can do there is running kubectl get nodes. It's going to show you how many nodes you have and if they're active or not. It's going to show you details about pods, for example, and a lot more. So let me quickly switch back to my command line, where the first step would be building up an integration between kubectl as the command line tool and your AKS environment. You would use AZ AKS get credentials. That would be the command pointing to the resource group in Azure, pointing at the actual cluster. And from there, without any typos at least, you could run kubectl get nodes. And again, I'm using the default, which means I have 3 virtual machines. Status is ready, they're waiting to be used. One of them is running for more than a year already, so pretty high available, no downtime whatsoever, and then expanding gradually over some demos. And I'm reusing version 1.18, and that's interesting to know. A little bit about supportability. So when we receive the new Kubernetes bits, we're going to test them on the Azure platform, and we're always 3 versions backwards compatible, which means if you would now connect to the Kubernetes website or deploying a new AKS environment on Azure, it would be version 1.21, and we're going to make sure that it's always 3 versions backwards compatible. From here, let me switch back to my Azure portal, just taking time into consideration a little bit. So what I already did is deploying a new AKS environment. Again, CLI, PowerShell, portal-based, ARM template, or overall infrastructure as code. That would be the scenario. So let's look into the cluster itself. So here on the side, we provide you some networking details. Whenever you deploy an AKS cluster, it's running its own Azure VNet. And from there, you can take ownership of the IP ranges. Internal pods only, internal public facing, that's up to you to decide, and that would be a setting of that YAML or Helm charts. Within my cluster, we have different services running, where the system services are literally what Kubernetes uses by itself to run. So it's going to provide, like DNS, it's going to provide monitoring. Literally the dashboard I'm showing you right now is backed by Azure Monitor and giving you that Azure-friendly management capability. If you use Kubernetes across different cloud platforms, you probably might look into another tool, which could be Azure Arc. It's an overall multi-cloud management tool for Kubernetes and virtual machines, by the way. Or you could rely on the default Kubernetes recommendation, which would be Prometheus together with Grafana for some nice dashboarding. What I did is relying on my YAML file, instructing the Kubernetes cluster like, hey, I want you to connect to Azure Container Registry, pick up that simple commerce, and the outcome would be any of these containers. My container service up here is publicly facing, so it's relying on Azure Load Balancer, and it's running a public IP address. So let's check back if my workload is running. You can already recognize the simple commerce, so everything looks pretty okay. And while it's loading, connecting to my database, let me drill down in one of the scenarios, because what I have here is one public IP address to the outside world, and I also have an internal IP address. Now, I talked about orchestration, talked about high availability, scalability, and what it means is that this container workload is actually based on 5 standalone containers that, again, we call pods in Kubernetes terms. And I can see my endpoints down here. So again, what it does is spinning up pod 1, 2, 3, 4, and 5, 5 of them for high availability. The AKS intelligence, or at least the Kubernetes intelligence, is guaranteeing high availability and uptime. What it's technically doing is mixing the 5 runtime pods across my different backend Kubernetes hosts. And you can validate that information from the workloads here, where you can see my 204 demo from another training I provided a couple of weeks ago. It's spinning up 3 of them, or it's spinning up 5 of them. So that would be the capability. From here, you can look into the actual YAML file that I used for running it. And you can see that I'm using a setting replicas 3, which means whatever happens within my Kubernetes environment, I always need 3 runtimes. Now, taking away a little bit of the magic, like what's running behind AKS, and it's relying on Azure Compute. So there's technically a virtual machine scale set. There's an Azure VNet. I'm using an Azure Load Balancer. I'm using a collection of public IPs. So although it's pretty powerful and offered as a service, in the back of the platform, it's relying on traditional virtual machine compute. But obviously, the main intent would not be to manage it from your virtual machine part of the platform, but managing everything from within AKS. And with that, we're close to the end of the session, where about an hour back, I started talking about the journey to the cloud. Where do containers fit in your containerization into an Azure public cloud or private cloud environment running on Azure or running on-prem, for example, on top of Azure Stack. I talked a little bit about Docker concepts, Docker command line options, and from there talked about different Azure container runtime services, ACI for a standalone build per second, container runtime, container WebApp for containers, where you have the Docker Compose option together with everything that you might already know from web apps, and ultimately you might look into a more high-end Kubernetes environment. And in between, I hope you enjoyed some of my demos. If you want to find out more about a lot of the demos that I did, I would say just have a look at my blog, because a lot of information is already documented there. So with that, I'm going to once more thank you, what I started with about an hour ago. Thank you for staying here till the end of my session. I hope you enjoyed it. I hope you learned a little bit from it. Feel free to stay in touch if you got any questions. Would be PDTIT on Twitter or petender@microsoft.com if you prefer email. Enjoy the rest of the conference and hope to see you again soon.